Assalamualaikum warahmatullahi taala wabarakatuh. We will continue our lecture with sharp corners. So sharp corners greatly increase the stress concentration. This high amount of stress concentration can often lead to failure of the plastic parts, such as reduced mechanical performance, material damage, high molding stresses, and possible cosmetic defects. An example shown here is the part of cantilevered snap arm. So the stress concentration factors here varies with radius for a given height. This is H for height. As can be seen from the chart, stress concentration factor is quite high for radius over height values less than 0.5. If we can see, when the value of R over H is less than 0.5, the stress concentration is quite high. For value of radius over height over 0.5 and above, the stress concentration factor gets lower, and the stress concentration factor is a multiply factor. It increases the stress. So actual stress is given by stress concentration factor K here times with stress calculated. Typically at corners, the inside radius that we should consider is 0.5. Okay, this is the good size of radius, while the thickness for outside and the outside radius, sorry, not thickness, outside radius is 1.5 times with material thickness. Okay, this is the example of sharp corner. So radius should be nice is if we use inside radius is 0.5 and the outside is 1.5. Okay, we proceed with ribs. Okay, rib. What is rib? Rib is a part features that can provide a means to economically augment stiffness and strength in molded parts without increasing overall wall thickness. Okay, so if we increase the wall thickness, it will lead to produce high weight of that parts, which is lead to increase the cost of material, increase the cycle time. So instead of increase the weight of the product, we can put rib. Okay, example of rib is this part. This is rib. Okay, this one is gusset. This one is rib. Okay, second purpose is locating and captivating components of an assembly, providing alignment in mating parts, acting as stops or guides. Proper rib design involves 5 main issues. First, thickness, height, location, quantity, and moldability. First, look at the rib thickness as a percentage of wall thickness. Okay, many factors go into determining the appropriate rib thickness. Okay, if we produce thick rib thickness, okay, it often can lead to produce sink and cosmetic problems on the opposite surface of the wall to which they are attached. So if you can see the table here, give common guideline for rib thickness for a variety of materials. Look at the polycarbonate resin. It produces highly glossy, critical surface may require thinner rib. Okay. Placing ribs opposite character marks or step can hide rib read-through. Ini contoh dia. Thin wall part, those with wall that are less than 1.5 millimeter can often tolerate ribs that are thicker than the percentage in this guideline. On part with wall thickness that are 1.0 or less, the rib thickness should be equal to the wall thickness. So we have two conditions for the thickness of the rib, 1.5 and 1.0. Okay, this image shows the example of thickness problem. This is the sink opposite thick rib. Okay, this one is a sink. Okay, it produce offset rib to reduce read through and sink. So dia buatkan lagi satu kat sini rib so that it can reduce this read through and sink. Okay, this figure, this image is rib thickness affect the warpage. Rib thickness also determine the cooling rate and degree of shrinkage in rib, which in turn affect overall part warpage. In material with nearly uniform shrinkage in the flow and cross-flow direction, thinner rib, this one is thinner rib, tend to solidify earlier and shrink less than the base wall. So in this situation, the end of rib surface may warp towards the opposite wall. Dia macam melengkung. So as rib thickness approach the wall thickness, this type of warpage generally decrease. However, ribs that are the same thickness as the wall may develop and that warp towards the rib side. Okay, to prevent this warpage, design extra more cooling on the rib side to compensate for the added heat load from the ribs. Okay, this is the example of glass fill material with high shrinkage in the cross flow versus flow direction. Okay, the effect of rib thickness on warpage can be quite different. Yang ni yang ada glass, okay, glass fiber. So kalau untuk thin rib dia melengkung keluar, untuk thick rib dia melengkung ke dalam, terbalik. Okay, for ribs height, standard rule of thumb limit rib height to 3 times the rib base thickness. So it means that it is 3 times of the thickness of this thickness. Okay, so inilah dia punya height dia. Very tall ribs are prone to buckling under load. Okay, so maintain enough space between rib. This is enough space between rib for adequate more cooling. For short ribs, allow at least 2 times the wall thickness. Maknanya dia kena ada 2 kali daripada thickness ni. Last but not least is the location and the number of ribs. We have to carefully consider the location and quantity of ribs to avoid worsening problems the ribs were intended to correct. For example, ribs added to increase part strength and prevent breakage might actually reduce the ability of the part to absorb impact without failure. Okay, so rib typically much easier to add than remove. So rib should be applied sparingly in the original design and added as need to fine-tune performance. Okay, proceed with bosses. Okay, bosses find used in many part design as point for attachment and assembly. So the most commonly variety consists of cylindrical projection with hole design to receive screws, threaded insert or other types of fastening hardware. So this is the example of bosses. This one, and also this one. Okay, this is bosses. Alright, this is some design criteria for bosses. You can read it. Orang tengah buat recording. As a rule of thumb, the outside diameter of bosses should remain within 2 to 2.4 times the outside diameter of screw or the insert. Okay, consider adding a recess to reduce the severity of sink. If the product is thick, so we put the recess around the base. This is the recess. Okay. So by adding the recess, we can reduce the severity of sink. Okay, this one, avoid bosses that merge into sidewall because that leads to sink. This is the incorrect figure and this is the correct figure. Okay, both of these is the figure from upper view of the bosses. Okay, so instead position the bosses away from the side wall. This is the side wall. And if needed, use connecting rib for support. Kita boleh guna this one is called as connecting rib. Consider using open boss design for bosses near a standing wall. Okay, normally the boss hole should extend to the base wall level even if the full depth is not needed for assembly. Okay, in order to maintain a uniform thickness, shallower holes can leave thick section resulting in sink or void. So this is not good. And if we use core too long, deeper hole reduce the base wall thickness leading to filling problem, nick lines or surface blemish. Okay. For this one, radius too large and this one is the correct one whereby boss hole should extend to the base wall level. Okay, sometimes bosses require a tall version of bosses. Okay, those greater than 5 times their outside diameter, it can create a filling problem at their top or a thick section at their base. So additionally, the core in tall bosses can be difficult to cool and support. This is some option to reduce the length of excessively long core pin. So consider coring a tall bosses from two sides or extending tall gusset to the stand full height rather than the whole bosses. So we put some gusset here, okay, to support the bosses. Other alternative include split. Okay, we split long bosses into two shorter mating bosses, or repositioning the boss to a location where it can be shorter. Macam ni. Kita reposition bosses tu supaya dia jadi pendek sikit. Okay, gusset. This is a gusset. Gussets are rib-like features that add support to structures such as bosses, ribs, and walls. As with ribs, limit gusset's thickness to 1/2 to 1/3 the thickness of the wall. Okay, if not, sink mark might be occurred. Okay, because specify proper draft and draw polishing to help with more release. Kalau kita guna dekat rib, maybe kita boleh design draft untuk senang dia eject. Okay, so the location of gusset in the mold still generally prevent practical direct venting. Avoid designing gussets that could trap gases out of the gussets and to areas that are more easily vented. This is the example of square gussets which can trap air in the